Hello, this is Mr. Henry, and welcome to Lesson 3.2. In this lesson, we are going to be solving multi-step linear equations. In the previous lesson, we did one step. Now we're going to move up to multi-step, so 2 steps, 3 steps, maybe more. The essential question says, how do I solve multi-step linear equations? Did you know that the cost of a speeding ticket in a lot of places can be calculated just using an equation? They charge you based off of how much over the speed limit you are going, and they usually add a bunch of court fees and other kind of fees onto it. So let's say, for example, if it's $5 for each mile per hour over the speed limit you're going. So if you're going 15 miles per hour over the speed limit at some place and a cop pulls you over, they would take $5 times by the number of miles per hour over the speed limit you were going, which was 15. And a lot of places they'll add in just some standard court fees of, say, $100. And then they'll put this in their computer and they'll do the math. And so 5 times 15 is 75. 75 plus 100 is 175. So you going 15 miles per hour over the speed limit could cost you a $175 ticket. This is not what they use in Pennsylvania. But this is what they use in, I believe it was Rhode Island. This is the formula that the cops use when you get a ticket. So we've got a couple of vocabulary words here, just very quickly. So first of them is the distributive property, which we've actually talked about back in Chapter 1 when we were doing the exponential properties. I used the phrase distributive property quite a bit when we had, like, if it was m to the third, n to the sixth, all raised to the eighth, and I said we're going to distribute that outside exponent to all the inside exponents to get like m to the 24th, n to the 48th. We were using the distributive property. The distributive property is when you take and you multiply the outside number by all of the terms on the inside of the parentheses. Now, in terms of what we're going to be doing, it looks more like this. That is more like a distributive property that we're going to see, where you take this outside number, the 5, and it gets multiplied by everything inside, because this says 5 times this stuff. And you can't just multiply by the first piece, you multiply by all the pieces. So this becomes then 15x. 5 times 3 is 15. 5 times 5 is 25. Okay. Like terms are terms that have the exact same variables. It's kind of important. They have to be the exact same variables. They have to, if one has an x, the other has an x. If y, y. Or even no variable. So if I have, let's say, 3x plus 2y plus 8, and another one of 5x plus, I don't know, 1y minus 12. The x's are alike. Those two are like terms. 2y and 1y are like terms. But also, this 8 and this minus 12 are like terms because they all have the same variable. X, x, y, y, constant, no variable, constant, no variable. So even this 8 and this minus 12 could be grouped together. Okay? Now, next to this in your vocabulary, or next to the did you know, you probably have a space that looks like this on your note sheet. There are 5 steps to solving an equation. Now, in this lesson, we are only going to be doing 4 of those. We are going to save step 3 for the next lesson. But we will be doing steps 1, 2, 4, and 5. So it'd be good to know what these steps are. And this is going to be kind of like a little checklist you can use. You can use this to go, okay, what do I do first? What do I do next? And next, and next, and go the whole way down from top to bottom when you're solving an equation. So the first thing you're going to do when you're solving an equation, just like order of operations, just like when we were doing the exponential properties, the very first thing you usually try to do is get rid of your parentheses. Get rid of parentheses. And the way we do that is by distributing. That's a U, not an I. By distributing. So we get rid of our parentheses by distributing. That's the first thing we're going to do. After you distribute, your parentheses will be gone. The next thing you look for is you look to see, can you combine like terms. And you combine like terms on both sides of the equal sign, because sometimes you can only do it on the left, sometimes you can only do it on the right, sometimes you can do it on both sides, sometimes you don't do it at all. Step 3 we're going to skip for right now. This deals with what happens if you have variables on both sides. That's not going to be this lesson. In this lesson, we're only going to have one variable, one x or one m in the problem. Step 4 and 5 we've already done in the previous lesson. So step 4 is we're going to get rid of the add and subtract. So if the variable is being added or subtracted by something, we're going to get rid of it. And we do that by doing the opposite. Get rid of add and subtract by doing the opposite. So if it's an addition, we subtract. If it's a subtraction, we add. And the last step is we're going to get rid of the multiply or divide. Again, that is also by doing the opposite. So if the problem has, say, 3x, we would divide by 3. Up here, if it was, say, 5x plus 12, we'd get rid of the add 12 by subtracting, whoa, what is that? By subtracting 12 on both sides. Okay? So let's get into it. First thing we're going to do here, the first few problems, I think 4, 5, 6, something like that, we are going to start by just simplifying. This is basically what these very first 2 steps come down to. These first 2 steps are going to simplify our problem. They're going to take our problem and they're going to make it look as pretty as it can look. There you go, simplify. So the way we're going to simplify is, first off, I'm going to get rid of my parentheses by distributing, if I can, and then I'm going to combine like terms. So I look here. Well, I can multiply this, and I can multiply that. These are 2 steps that I can actually do right now. I can take 3 times 2x. This is not distributing, but it's multiplying. I can simplify. So 3 times 2x is 6x. And 5 times 3 is 15. I cannot combine these 2 terms together because this guy has an x and this guy does not. They are not like terms. Like terms have to have the exact same variable. Letter B. I see I have these parentheses, so I want to get rid of my parentheses. Now this is an example of distributing. Do you see how I have 2 separate pieces inside my parentheses? Well, this 3 needs to multiply by both of them. So I'm going to take the 3 times by the 2a, which is 6a, and I'm going to take the 3 times by this minus 6, or negative 6. It is technically a negative 6. 3 times by the negative 6 to get negative 18. And write down the rest of the problem. So there's my 4a from here, and my symbol here. Well, 3 times 2, this is a positive 3 and a positive 2, gives me a positive 6. So I've distributed. That's what this first step was. I multiplied this outside number by the inside numbers. Now I look here and I see I've got a 4a plus a 6a. I can combine those a's together. I don't need to have 2 separate terms with the same variable. I'm going to group them together. And 4a plus 6a is 10a. It's the same variable. 4 plus 6 is 10. And this negative 18 or minus 18 just comes along for the ride. Distribute, combine like terms. Multiply, nothing else to do. Okay. Now, I'd like you to try these 2. I do have letter D labeled as a challenge. I would like you to try it. There's a particular mistake that a lot of students make. Not everybody. But I'd like you to try these 2 problems if you could, please. Pause the video. When you're ready to continue, hit play, and we'll go through it together. Okay, so letter C. I can multiply this. I can multiply that. 2 times 3 is 6. 4 times 5 is 20x. I cannot combine my like term, or I cannot combine these terms because they are not alike. This guy has an x, this guy does not. Letter D. Now, here is the problem. A lot of students would start by distributing. You would just take this guy times here and times here. You get 3h minus 15, which is absolutely fine, and that is correct. The problem happens in the second set of parentheses. A lot of students don't know what to do here, and so sometimes they just go like this, and they just kind of drop the parentheses and bring it down, which is not right. So what this is, there is something right here that is being multiplied by these parentheses. What is it? Your probable guesses are either it's a 1 or a 0. Well, 0 wouldn't make sense, because if there's 0 of these things, we wouldn't write it at all. It is 1. It is negative 1 times by this stuff. This is a very, very, very common mistake that a lot of students make. And if you made it, that's fine. It is negative 1. So when we multiply here, when we distribute, we need to take negative 1 times 2 and negative 1 times h. Now what happens here? Negative 1 times 2 is negative 2. Negative 1 times by h is a negative 1h. And I don't need to put the 1 there. It's a ghost 1. Now, if you got stuck and you didn't even get this far, okay, fix what you have, get yourself caught up to here, and then what I'd recommend is pause the video and see if you can combine like terms from here. Okay, if you kept going farther and you got this part right, well, let's keep going. So I'm going to take my 3h and my minus h. 3 of them minus 1 of them. 3 minus 1 is 2h. And I'm going to take my minus 15, see he's a negative 15, and a negative 2. If I combine negative 15 and negative 2, and when I say combine, I'm talking about add. I add negative 15 and negative 2. That's how I do this in my mind and got negative 17. Some people might go, okay, that's negative 15 minus 2. Negative 15 minus 2, you still get negative 17. And if you're going, that's a minus 15 and a minus 2, well, that's not really a minus 15. There's one of the tricks that maybe you remember, if this confuses you. Do you remember doing keep, flip, change, KFC? Whenever there's a rule when you're subtracting integers. If you have like 5 minus 7, you keep the first number the same, you flip the sign from minus to plus, and you change the sign of the second number. So 5 minus 7 turns into 5 plus negative 7. That works here too. So you can go, okay, that's plus a negative 15, plus a negative 2, plus a negative h. If you like to do that, you want to change your minus signs to plus a negative, by all means, do it, if that's helpful for you. Okay, now you can see it's negative 15 plus negative 2, and that's 3h plus negative h. You get the same answer that we got here. Okay, so distribute, combine like terms are the first 2 steps. So now we're going to get into some honest solving equations. So here is my line down the middle of the equal sign. So I have 2 things to get rid of here. I'm looking at my problem. I see I do not have any parentheses to get rid of. I see I do not have any like terms here. I cannot add anything here, and I cannot add anything here. I'm on to step 4. In step 4 here, I have 2 pieces. I have a multiply by 6 or a plus 11. Which of those would you get rid of first? Well, according to our rules, we get rid of the add and subtract before multiply and divide. So, to get rid of this plus 11 first, I'm going to subtract 11 on both sides. When you do that, this 6m still comes along for the ride. He's still there. But over here, 83 minus 11 is 72. Now, since it's 6m equals 72, now I can get rid of this multiply by 6. See, it's multiply. So the way we get rid of a multiply is we divide by 6 on both sides. These guys cancel out, giving you 1 1m, 1m. 6 divided by 6 is 1. On the other side, 72 divided by 6 is 12. Now, let's say you did a problem. I'm not sure if I did that right. Paint bucket. There we go. You're not sure if you did it right. How do you check it? Well, you take the number you got for your answer and you plug it back in for the variable and see if the math works out. Is 6 times 12 plus 11 equal to 83? I don't know. Calculator. 6 times 12 plus 11. Yes, 6 times 12 plus 11 is 83. So this math checks out, which means this is the correct answer. Okay, that's how you check your answer after you solve. Letter B. Now, looking at this already, I can see I can simplify this a little bit. There's no reason for this to be a 7 parenthesis 2, 7 times 2. I can just make that 14. If you want to do it the next step down, you can do it that way as well. So now we have this, and we want to solve. So I have no parentheses. I cannot combine like terms. There's nothing to combine on this side, nothing to combine on that side. I get rid of my add and subtract before multiply and divide. That's going to be a common phrase you're going to hear me say a lot because a lot of students need to hear that. And it's true. You always get rid of the add and subtract before the multiply and divide. The one that is attached to the variable is called the coefficient. The one that is attached to the variable is always the last thing you get rid of. The ones that are separated by a pluses and minus signs are the first things you get rid of and you move to the other side. So here, when I add 13 to cancel out this minus 13, we get b over 3, he comes along for the ride, equals, this is gone. 14 plus 13 is 27. Now, in order to solve this, my variable is being divided by 3. So the opposite of divide by 3 is to multiply by 3 on both sides. So 3 divided by 3 is 1b, which is what we wanted. There's 1b now. 27 times by 3 is 81. Okay? Get rid of add and subtract before multiply and divides. The multiply and divides, the coefficient, is always the last thing you're going to get rid of. Looks like I got a couple more we're going to do together, and then you got a couple you're going to do by yourselves. So here is letter C. Now, this problem may look a little bit different because the variable's on the other side. It doesn't change the difficulty of the problem, it just makes it look a little uglier. If you don't like this and you wanted to flip-flop the whole problem, if you made it like 4 times 3k minus 4 equals 20, like this, you could. I'm not going to, but you could do that, and you'd get the exact same answer. So my solving here, I see I have parentheses here. So I'm going to start by distributing. That's going to give me 4 times 3 is 12k. 4 times by a negative 4. 4 times negative 4 is negative 16. Okay, distributed. Parentheses are gone. Combine like terms. I do not have anything I can add together here because these do not have the same variable. There's nothing I can add together here. Next, get rid of add and subtract before multiply and divide. So I'm going to get rid of this minus 16 here. So I'm going to add 16 to both sides. Now when I do that, these 16s cancel out. I'm only left with a 12k on the right. On the left side, 20 plus 16 is 36. Now to continue and solve, my variable is being multiplied by 12, so I divide by 12 on both sides. These 12s cancel, giving me 1k. 12 divided by 12 is 1. 1k equals 36 divided by 12 is 3. Letter D. Letter D looks a little bit uglier because it has this fraction in here. But if you remember from the previous lesson, the way we're going to get rid of that fraction is by multiplying by the reciprocal. Okay, we'll get there. But first, let's worry about the other stuff, because that 1/9 is going to be the very last thing we get rid of. So I'm looking at my problem here, and I see, well, I don't have any parentheses to get rid of. I cannot combine any like terms. I've got a D here, but there's no other D's. And this guy doesn't have anybody to combine with. So now I'm going to be doing that, getting rid of add and subtract first. So I look here. What is being added or subtracted to this piece? Well, this piece. And how do I get rid of that? Well, if this is a minus 14, you use a plus 14. If it's a negative, you use a positive. So I'm going to be adding 14 to both sides. Now that gives me, over here, negative 8 plus 14 is 6, positive 6. These 14s are cancel out. They're gone. That's why I added 14, is to make these cancel. And on the other side, I still have a positive 1/9 D. Now, I'm going to finish solving. So to get rid of this times by 1/9, I am going to multiply both sides by the reciprocal, times by 9/1. That makes this fraction, this coefficient, equal 1. I get 9/9 D, which is 1 D. On the other side, when you multiply the fraction, 9 times 6 is 54/1. I don't really need to put over 1. 54/1. And that is done. Okay. Here are 4 for you to try. These are letters E, F, G, H, so if you could please pause the video, copy the problems down, do them. When you're ready to continue, hit play, and we will go through them together. Okay, so I'm looking at letter E. Actually, I don't see parentheses in any of these, so I don't have to distribute in any of these. What I do have to do is, well, I don't have any like terms either. So I'm going to start by getting rid of my add and subtract. So to get rid of this plus 6, I'm going to start by subtracting 6 on both sides. That gives me 1/3 H equals, let's see, 14 minus 6 is 8. And now to get rid of a 1/3 times by the variable, we're going to multiply by the reciprocal. That makes this become 3/3, which is equal to 1 H. On the other side, when we multiply by that reciprocal, 3/1, we get 8 times 3 is 24/1, which is just 24. Letter F, there's no parentheses to get rid of. There's no like terms to combine on either side. So I'm going to start by getting rid of the add and subtract. So I'm going to subtract 2 on both sides to get rid of the plus 2. That gives me 9R is equal to 36. My variable is being multiplied by 9, so I get rid of it by dividing by 9 on both sides, and we get R equals 4. You notice I'm picking up the pace. This should be becoming familiar, and it's the same steps that we were working on in the previous lesson. It's just doing it more times. Here, my variable is being divided by -4, and it's also being subtracted by 3, or added by a -3. So the first thing we're going to get rid of is this -3 out front. Get rid of add and subtract first. So to get rid of a -3, I'm going to use a +3. 4 plus 3 is 7, and this is a place that I've actually seen some mistakes in the past. So caution yourself here. Do you have just W/4? If you do, you made a mistake. This negative sign here kind of needs to follow you along. This is a negative whatever this term is. That sign sticks with this. So you can't just drop the negative from one step to the next. Now, you can actually decide where you'd like that negative to be. If you'd like to think of it as a negative w down below, you can. If you want it to be a negative w up top, you can. I'll be honest with you, in this problem, it's probably easiest to think of the negative down here. Because now you can say, oh, it's w divided by negative 4. So to get rid of it, I would multiply by negative 4 on both sides. And then these guys would cancel, giving me 1w. And on the other side, negative 4 times by 7 is a negative 28. Last of them on this page, we have letter H here. Now, in letter H, we do have some combining like terms to do. I have a 15 plus 9, which is, what, 24. On the other side, I have 5 G's and 3 G's, which can be combined together. 5 G's and 3 G's make 8 G's. Now from here, when we solve, since my variable is being multiplied by 8, I'm going to divide by 8 on both sides to make these cancel, giving me 1 G. On the other side, 24 divided by 8 is 3. Now, I haven't checked a problem in a while, so let me just show this checking your solution here. I have 2 G's. If I'm trying to plug in 3, I'm going to plug it in for both of them. All of the G's need to equal 3. So 5 times 3 is 15, 3 times 3 is 9, 15 plus 9. And I can already see that this is going to be equal because 15 plus 9 equals 15 plus 9. Yes, yes it does. Both sides would equal 24. So when G equals 3, it makes these two sides equal to each other. Okay, getting a bit more complex, more stuff to them. Letters I and J. Go ahead, pause the video, try these two on your own. When you are ready to continue, hit play, and we'll go through them together. Okay, so you probably started by distributing over here. I like that. That gives me 4 plus 8, which I can just right now erase. 4 plus 8 is 12. So I don't even need to write a separate step for that. Just 4 plus 8 is 12. So you can say that's 4 and that's 8 and combine them together to get 12. On the other side here, actually I can combine these like terms. I have negative 9r here plus 3r there. These guys, when I combine them together, negative 9 plus 3 is negative 6r. So check your first step. If you did this in 2 separate steps or 3 separate steps, that's fine. Now, from here to solve, negative 6r equals 12. I need to divide both sides by negative 6 to cancel out this times by negative 6, giving me 1r. On the other side, when I divide by negative 6, 12 divided by negative 6 is negative 2. Letter J. Looks ugly. Distribute, distribute. So this 2 times m is going to be 2m. 2 times by negative 8 is a negative 16. I'm writing down the rest of the problem, so I did this math right here. Now, I look over here and I see I actually have 2 terms with m's in it. I can combine them together. I could not combine them in the first step because this guy was stuck inside the parentheses. I had to do it after I've distributed. So now I can take these 2 pieces and combine them together. Negative 3m plus 2m. Negative 3 plus 2 is negative 1. Okay, so I did this one step, combined like terms. Now, I'm going to, am I going to get rid of this negative 1 first or this positive 16? Well, the plus 16. You get rid of add and subtract before multiply and divide. So I'm going to subtract 16 on both sides. Negative 1m equals 26 minus 16 is 10. And then finally, to get rid of this negative 1. Now you might be thinking, Mr. Henry, it's a 1 out front. Can't I just erase it and get rid of it? Unfortunately, no, because it's a negative. Because it's a negative m, you actually have to go through the process of getting rid of the negative as well. So this is just negative 1 times by m. So I'm going to divide both sides by negative 1. That makes these negatives cancel. Negative divided by negative is a positive. So now we have positive 1m equals 10 divided by negative 1 is negative 10. I believe these are the last 2 of this type. So if you could, please pause the video, try these 2 problems on your own. When you are ready to continue, hit play, and we'll go through it together. Okay. Simplify. 4. Simplify. Negative 2b. 5b's minus 7b's is negative 2b's. Once you've simplified both sides, look at this. It's a simple one step from here. We're going to divide both sides by negative 2. Cancel. And b equals 4 divided by negative 2 is negative 2. Letter L. Lots of junk going on here. I'm not going to actually move him a little bit further into the middle of the screen. Alright, lots of stuff going on here. But the first thing I see that pops in my head is I have these parentheses here. I have to distribute to get rid of them. So this math is going to come up with 4g plus 4. I'm going to write down the rest of the problem. There's a negative 4 out front, a positive 2g in the back equals 24. Combine like terms. I actually have a couple things I can combine here. I have 4g's here plus 2g's here. So they're all positive, so that's going to give me 6g's. I have a negative 4 out front, a positive 4 in the middle. When I combine negative 4 plus positive 4, that equals 0. Okay, on the other side we get our 24. Now, I don't really need to write plus 0. And just for sake of prettiness, I'm going to move him over. So this whole line, the positive 4 and the negative 4 canceled, and the 4g and the 2g gave me 6g. From here to solve, since this is a 6 times g, I'm going to divide both sides by 6. These cancel out, and we get g is equal to 4. 24 divided by 6 is 4. Applications. Problem solving. To rent a booth at the county fairgrounds costs $42 per day, plus a one-time equipment fee of $85. Find the number of days Mr. Batzel rented the booth if he paid a total of $337. Okay, so he's going to pay a bunch of money. It says it cost him $42 per day, plus a one-time fee of $85. Find the total number of days Mr. Batzel rented the booth if he paid a total of $337. Okay, so this is my verbal model. This kind of summarizes the word problem using letters, numbers, words, symbols, but it kind of makes it look sort of like an equation. And the question is, find the number of days. I don't know this. That's going to be my variable. How many days did he rent the booth? So $42 times by the number of days plus this equipment fee is equal to $337. So look at my verbal model here and look at my equation. Look how similar they are. That's why I do the verbal model. Because if I said if you went straight from here to here, a lot of students would be confused. Now we solve. So to solve here, I'm going to, well, there's no parentheses, there's no combining like terms. Get rid of my add and subtract. Subtract 85 on both sides. These cancel, giving me 42x equals 337 minus 85. 337 minus 85 is 252. Now, since this is a multiplication, I'm going to divide both sides by 42. Divide by 42. These cancel, giving you 1x. Now on the other side, 252 divided by 42 equals 6. So Mr. Batzel rented the booth for 6 days. 6 days at $42 a day plus the $85 would give you a total of $337. Letter B. A farmer has a field with 19 pumpkins, or 19 rows of pumpkins, and a small side field with 12 pumpkins in it. Both fields have a combined total of 107 pumpkins. If the farmer doubled the number of pumpkins in each row of the large field, how many pumpkins would he have? So this problem would be best solved, or I would start by solving by drawing a picture. So here's his field with 19 rows of pumpkins, plus a small side field with 12 pumpkins in it. These two fields have a combined total of 107 pumpkins. If the farmer doubled the number of pumpkins in each row, which, by the way, I don't know. I don't know how many pumpkins are in each row. I know there's 19 rows of them. I don't know how many are in each row. If he doubled the number of pumpkins in each row of the large field, how many pumpkins would he have? So, in order to answer the question, I have to first figure out, well, how many pumpkins does he have? This is kind of like my verbal model. Okay? This says to me, if I take 19 times by x, that would tell me how many pumpkins are in this large field. I have 19 rows times by however many pumpkins are in each row. And then if I add 12 pumpkins from this other field, that would give me my total of 107 pumpkins. So this is like my verbal model. Now, when I solve here, I would start by, well, there's no distributing, there's no combining like terms, so I start by subtracting 12 on both sides. We get 19x equals 107 minus 12, clear. 107 minus 12 is 95. And now I have 19x equals 95, so if I divide by 19 on both sides, let's see, I get 95 divided by 19 equals 5. So x equals 5. He has 5 pumpkins in each row. Okay. So 19 rows times by 5 pumpkins in each row gives you 95 pumpkins, plus this other 12 takes you up to a total of 107. The math works out. Now the question is not done. The answer is not 5, because the question says if the farmer doubled the number of pumpkins in each row of the large field, how many pumpkins would he have? So if you took this and you doubled it, double means times by 2. So then he would have 10 pumpkins in each row. Still has 19 rows, still has these other 12 pumpkins. How many total pumpkins would he have? Well, this guy, the large field, would have a total of 190 pumpkins now. Length times width. Plus the small side field of 12 pumpkins gives you a total of 202 pumpkins. Multi-step problem. I set up a picture that matched the scenario. I used that to help write my equation. I solved the equation. I then didn't just settle with this for an answer and go, okay, I'm done. I went back and I saw that it says if he doubled the number of pumpkins in each row, how many pumpkins would he have? So then I took the answer I got, I doubled it to get 10. Then I just did some quick math to find out how many total pumpkins that would be. Letter C, this is one for you to try. You do not have to write the problem down, but you do have to do it. It says here that Nathan is an avid stamp collector. That means he likes doing it. For 9 weeks, he bought stamps. If we add those to his collection of 45 stamps, he now has a total of 252 stamps. How many stamps did he buy each week on average? So if you could please go ahead and set up your equation and solve it and see if you can find the answer. Pause the video. When you're ready to continue, hit play, and we'll go through it together. Okay. So for 9 weeks, he bought stamps. So he bought stamps for 9 weeks. If we add those to his collection of 45 stamps, he now has a total of 252. Whoa. Verbal model. Now, let's turn this into an equation. How many stamps did he buy each week on average? I don't know. That's the question. We know he bought them for 9 weeks, so each week he bought some stamps. I guess I'll use an S for stamps. Be careful using S because they kind of look like 5s, at least mine do. So each week he bought stamps for 9 weeks. Plus those 45 he already had. Now he has 252. So how many stamps did he get each week? I don't know. But if we take the 252 and we start solving this equation by subtracting 45, 252 minus 45 is 207. So in those 9 weeks, he bought 207 stamps. If we divide by 9, that will tell us how many stamps he got each week on average. So on average, he got 23 stamps. 207 divided 9 is 23. So each week he bought an average of 23 stamps. So imagine he bought 23 stamps 9 weeks in a row. And then if you add that to the 45 he already had, he would now have 207 stamps. I'm just doing this over here just to make sure that the answer we got makes sense in my brain, and it does. Alright, so example D. Given a right triangle, find the size of the angles if one angle is 10 more than 4 times the other angle, and the third angle is the right angle. Now, I can understand that being a little confusing, so I'm going to give you a little hint to start you off. So we'll start by drawing a picture. If you don't want any hints, you can pause the video and try it on your own. So it says I have a right triangle. It says this third angle is the right angle, which we know is 90. Now, given a right triangle, find the size of the angles if one angle, let's say this guy right here, is 10 more than 4 times the other angle. So 10 more than 4 times the other angle. And it doesn't really say what this other angle is, so we're just going to make it x. So if this is x, this one is 10 more than 4 times x, and the third one is 90. That is fairly hard to come up with on your own. But from here, let's see what you can remember about triangles and see if you can find out how big those angles are. This does take some background knowledge on triangles. So go ahead and pause the video, try it on your own, see what you can come up with. If you get stuck or if when you're done, hit play and we'll go through it together. Okay, so what you had to remember about triangles is that if you add all 3 angles of a triangle together, it equals 180 degrees. That's the background knowledge you needed. That's the creativity here that you had to come up with, kind of thinking outside the box. So if I add my three angles together, I have 90 plus x plus 10 plus 4x. Those are my three angles that I have here in my picture. This plus this plus this all together have to equal 180. Now, if I solve this equation by combining like terms, I have and let me get rid of these underlines here. There. So now I have a 90 here and a 10 here that I can actually add together. That's 100. And I have a 4x from here and a 1x from there that I can combine together. Those are like terms. 4x plus 1x is 5x. Now, we solve. Now this looks fairly easy, and maybe you didn't get this far. And if you didn't, that's okay. Get yourself caught up to here, and then what I'd recommend is to practice solving, pause the video, try to solve it on your own, and then hit play when you're ready. For everybody else, we're going to go through it right now. So we're going to, we're going to get rid of the add and subtract before this multiply. So I'm going to subtract 100 on both sides. These cancel out. We get 5x equals 80. Then, to get rid of this times by 5, I'm going to divide by 5 on both sides, giving me 1x equals. And then 80 divided by 5 is 80 divided by 5 is 16. Had an idea, but I didn't want to say the wrong thing. So it's better to check. If you're not quite positive, check it. I'd rather you get a right answer than a wrong answer you took a guess at. So this is actually not quite the finalized answer. I know this angle is 90. I know this angle is 16 because x is 16 and this was labeled as x. But this guy over here, what is he? Well, I know he's 10 plus 4 times 16. So if I plug in 10 plus 4 times 16, and I do this math, order of operations says you should do the multiply first. So 4 times 16 is 64, plus 10 is 74. So this angle is 74, this angle is 16, this angle is 90, and to double check my math, if all three of those are added together, they should equal 180 degrees, and there we go. The three angles added up equal 180. So, summary. Says, in words, describe how to solve this equation. So give me steps. First you do this, then get an answer. Then you do this and get one answer. Finally you do this and get a solution of. Okay, so I kind of got you started with little sentence starters here. So you can do that on your own. This has been lesson 3.2. Thank you for watching.